Well, next speaker, who's Mahesh. If you're there, Mahesh, let me
Hi.
just see if I can. So we see you. I think we can
Yeah.
hear you. You said hello. Are you sharing
Yes.
slides with us?
Yeah. I have sharing rights. Just a second.
You should do. Yeah, with any luck. So
Yeah.
down the bottom, there's a share screen. Okay, it's just coming up now. And if you can change that into the presenter mode so we get it full screen.
Just give me a second.
No worries. That should do it.
Is it visible now?
That's visible. You're good to go. I'll stop you in about 19 minutes or so.
Perfectly fine.
Thank you.
So good afternoon, good evening, in whichever part of the world we are. I'm Mahesh Patil. I'm a freelancer. And today we will discuss about the Sawrm impact of Tibet and possible ancient observation. So in the last 100 years or so, we have observed Tunguska impact. And despite of having all eyewitness accounts and scientific investigations, we haven't been able to successfully conclude the search. Rather, there are many unanswered questions and there are still ambiguities. There's a possibility in known human history. We have observed certain events, celestial events, which our ancestors across the globe observed and tried to record it in the form of legend, rock art, ancient writings. But the main challenge while using these references is the methods followed and the belief system which they had. And that makes it very difficult to use them for a scientific work as a reference. However, there is no harm in taking clues from these records and try to evaluate them on a modern scientific scale to find out the real truth. Sawrm impact of Tibet is one such, you can say, find or attempt to establish a correlation between the ancient and the modern observations. This is the site we are talking about. We understand it's a very large impact site, very difficult to prove. Even a small crater takes time, but we are attempting it using modern evidences like tektites, inclusions in tektites, proposed impact craters, ultra-high pressure findings. All these things we are going to correlate, or rather we located this site using certain ancient observations, which we'll describe in detail. But before we do that, we will first evaluate modern evidences why Tibet is a possible impact site, first of all. So tektites is the main thing all of us know. Entire Asia and Australia is the biggest strewn field for tektites. Laos, Thailand, Vietnam, Cambodia, everywhere we have tektites. Rather, this is the youngest and the biggest strewn field known to mankind. By and large, there is a consensus. It is formed by a highly oblique impact on Indochina border. Coibrel is a strong supporter of this theory. Expected crater is around 70 kilometers. Unfortunately, despite of having such a young field with an expected large crater, we haven't been able to identify crater till date. If we look at the classification of tektites which are reported from this area, there are heterogeneous Myeongnam, which weigh up to 24 kg, and homogeneous splash-form tektites. Myeongnams are restricted only to Asia. They are not found in Australia. And thus, for this study purpose, we have restricted our search area only till Asian tektites. We are not extending this field to Australian one as of now. Volatiles present in Myeongnam suggest that they are formed by impact of a comet. Abundance of lithium, boron, and kyanite can be used to trace the impact site or a target rock. That's what Ian Coibrel has been advocating for long. Tibet Lake region is one of the areas on Indochina border where lithium, kyanite, and borax deposits are found, and borax can be responsible for boron. There are unconfirmed reports of tektites from Tibet and Myanmar. There are no official reports, but yes, there are studies which are conducted. There are samples which are tested. Only thing, method of collection of sample was not appropriate. That's why it is considered as unconfirmed report of tektites from Tibet. So when we discuss the Asian strewn field or Australian strewn field, ideally it should start from Tibet. That's what we feel. Before we discuss the strewn field, we need to understand the basic difference between the oblique impact vis-a-vis the normal impact. Schools has done a great work by using Hell crater as one of the reference point followed by laboratory experiment. The major difference is with the fate of projectile. In normal impact, projectile generally melts instantly. But in case of oblique impact, ricocheting has been observed in laboratory experiments as well as theoretical experiments. Skulls have strongly suggested that in case of oblique impact, failed fragments continue to traveling downrange in ballistic trajectory at a velocity close to initial impact velocity. This ejecta is generally concentrated in a narrow fan localized within that area, and trajectory is axis downrange. Thus, the strewn field of an oblique impact is mix of melt from target rock as well as from projectile fragment. These are the key differentiator of an oblique impact than a normal impact when we consider the ejecta distribution. So now, if we look at strewn field of Asia for this study purpose, and we assume that Tibetan unconfirmed report can be considered as a reference point to evaluate this strewn field, then it works out to be a narrow fan distribution. Tibet looks like a starting origin. However, tektites are concentrated mainly in Asia. This concentration of Myeongdong around Vietnam, Cambodia, Laos, and Thailand is one of the reasons why search for impact crater is restricted to this area, because Myeongdong are large 24 kg tektites, and understanding is that they wouldn't have traveled a much larger distance from the source crater, and thus the entire search is restricted to this place. So the question is that if Tibet is impact site, then can Myeongdong kind of a tektite travel such a long distance? So when we do a basic trajectory calculation using the oblique model, assuming the ricocheted fragment continue traveling at a velocity closer to impact velocity, okay, then at 8 to 10 kilometer per second velocity, if these fragments are traveling at an angle of 5 to 10 degree, which is the oblique impact angle, then they can cover distances up to 3,000 kilometers. So there is no harm in evaluating Tibet as a possible impact site. The bigger question here is now, is there any source crater at Tibet? So there are, if we have identified few craters, we have classified them into two parts. One is small craters, which may be sibling craters, because in oblique impact you have sibling craters which are formed around a parent crater, or they are caused by fragments. These craters are having diameter up to 1 kilometer. They have clear features like ejecta blanket, crater rim. They can be differentiated very well from erosional features. We have kept erosional features and glacial lakes or structures looking like glacial lakes away. We have also considered the man-made structure possibility using the temporal data of satellite imagery. Then there are parent craters or larger craters. These are oblique shaped craters, but obliterated feature. They are not very clear. So first we'll look at smaller craters. We have used Satellite Pro and Sentinel standard false color composition image to locate these and identify these craters. So this is the first circular depression with a clear rim kind of a structure. It's a 1 kilometer structure. For 16 years, we have checked the temporal data. There is no change. There are no roads or no human activity in the surrounding. So with in a safe manner, we can say this is a 1 kilometer structure, which is a potential impact structure. Obviously, a field investigation is a challenge because there are geopolitical issues and we are looking for association with people who have access to this region. This is the second crater, which is again a small circular depression of 600 meters. Images again taken from Satellite Pro as well as Sentinel data. Here we can see the ejecta blanket kind of a thing around the crater, which is coming out of the crater. This is the third one, which is much more clear. It's a smaller crater of 100 meters. Image from Sentinel is not that clear. That's why we have not taken that image into account. So, but ejecta blanket in this case is very well defined. The crater rim is very well defined. We have identified 10 such structures. And these structures are around the lake region, what we are proposing as the possible impact site. Yes, we again reiterate that field investigation is required. Whatever we are saying is based on the satellite imagery. We haven't done field investigation. If we want to look at the larger structure, before we discuss the larger structure, we would like to discuss two factors which affect the shape of an impact crater. One is angle of impact, as we discussed. Possibility of 5-degree impact or 10-degree impact is hardly between 0.75 to 6.5%, as Schumacher has predicted. It's a very minimal possibility of having a highly oblique or grazing impact, but it can't be ridiculed. In that case, crater will not be circular, it will be elliptical in shape, and it will be very elusive crater. Second, density of projectile matters a lot. As Rudy as well as O'Keefe have suggested several times, low density objects give birth to different cratering, which will be more of a flat fall or a multi-ring kind of a crater. So right now we are evaluating two possible craters. First, we will discuss the ICL model of 5-degree impact as well as 10-degree impact. In both the cases, we can clearly see projectiles sliding first and then creating the elliptical shape. So the craters are very elongated. There are two lakes in Tibet which we have identified right now. First is Lake Selinko and Lake Daxiko. In both the cases, we can clearly see some kind of a tail or a sliding pattern, and the right hand side of the structure, both in all these lakes, the right hand side has a circular or elliptical shape. The left hand side or the western part has a drag or a sliding kind of effect. Whether it's Lake Daxiko, this Lake Selinko, there are a couple of other lakes which we have found out. In most of the cases, this pattern is observed. The interesting part is, in all these cases, near the lake discharge, we have seen industrial activity or placer mine kind of activity. Again, it is without field investigation based on satellite imagery. But yes, there is a heavy activity going around in the lake region, which suggests that lake are discharging some key minerals, or they are source for something which is commercially important. Now, these craters, do they have some metamorphic evidences? Ultra high pressure minerals have been reported from Lubusa ophiolite. Lubusa ophiolite is exactly beneath or below this lake region in mainly placer deposits. Basis cosite after stishovite with well preserved grain, microdiamond, titanium dioxide 2, osbornite. Earlier studies have predicted the possibility of impact, but they never ever found crater in their study, and that's why they have favored mantle origin as the source of these findings. But surprisingly, for a low for these placer deposit, oxygen fugacity is very low, and it's going to play a critical role. Apart from these findings, which are generally associated with impact craters like cosite after stishovite or microdiamond, there are two exclusive findings: cubic boron nitride and boron carbide. Now, these are not natural findings. On entire Earth, we haven't reported any such findings in natural environment. So these findings are surprise findings, and right now they have been included as mantle origin, because cubic boron nitride require pressure again, which is around 350 kilometer. However, we feel there is a simple explanation possible in this case. A cometary impact can explain this, because what you need for formation of cubic boron nitride is ammonia and boric acid. Borax is already available on the surface of Tibet Lake. 1300-degree temperature and pressure of 10 GPa is easily possible in case of impact event. So boron nitride can be more convincingly justified by impact of a cometary body having ammonia. If there is a comet impact, then carbon monoxide is also a part of a comet. At 1300 degree, when it reacts with a borax or boric acid, it is going to provide boron carbide. Osbornite, titanium dioxide, stishovite, all of us know in the event of impact, these are not new findings. They can be justified. So this diagram provides a simple explanation. Comet acts as a source for ammonia, water, and carbon monoxide required for these transformations. Pressure and temperature is included in it. After impact, when temperature is generated, this melt gets rapidly cooled. That ensure these findings are found near surface in association with each other. That's the case with Tibet right now. And rapid cooling ensure encapsulation of these minerals that ensure they maintain the low oxygen fugacity. Second explanation is yes, a mantle origin, but there are certain key questions that are required to be addressed. First, they are found in ophiolite. Ophiolite is not a deep mantle phenomenon, and definitely not 350 kilometer phenomenon. It's somewhere around 30 kilometer. Second, they are found in placer deposits. So it's very difficult to understand how 350 kilometer finding is getting reported, or formation process is getting reported in placers and in ophiolite. Second, for justifying cubic boron nitride, there is no known source of boron in the mantle, at least as of now. Same is the case in nitrogen. It requires a detailed explanation. Rather, Tibet lake surface is a easy source of borax which is required, or boric acid which is required for formation process. Low oxygen fugacity required encapsulation. So when these findings were transported from deep mantle, this perfect encapsulation and well-preserved cosite grain looks very, very difficult. Last and most important point, these findings are found in association with each other. All these things require different depth and temperature pressure conditions. So their association looks difficult in a practical world. So we are not saying mental origin is impossible, but at the same time, we strongly recommend that impact is a possibility. It can't be ridiculed without studying these structures. Now, question is that just to explain, the Yarlung Zangbo region is where these placer deposits are found. Right now, researchers are saying there is no impact evidence in Yarlung Zangbo. However, Yarlung Zangbo region get water from these lakes as indicated. The yellow lines are indicating the river channels or water channels. There are multiple channels that are the main source for Yarlung Zangbo. So without studying these lakes, and especially when there are industrial minings happening in the lake region, impact should not be discarded. That's our argument. Now, question is that how did we reach to this site? Well, I'm not a geologist. I don't have much of a background. I started evaluating this basis certain ancient data. There are local legends which talk about certain events which have similarity with the impact of a comet. There are rock arts, and then there are Vedic references or ancient literature in Sanskrit which describe certain events which indicate that this region has observed impact in past. We will talk about one such legion from Ramayana. It talks about Ganga descending from heaven to earth. I'll just narrate the crux of the story. Again, I'm repeating, we don't want to mix belief. We are assuming that whenever there is a large event like Tunguska, people have their own stories and own versions. We would like to keep the belief away and focus on the scientific facts. The story goes like this, or local legend goes like this. A daughter of snow was revolving in the snow, revolving in the heaven. When she was asked to descend on earth, she threatened that my earth will not be in a position to bear my velocity. It will face major damages. There will be a catastrophe. So Lord accepted to hold her in his head, and he promised that you don't worry, I'll take care of that. And when she fell on the head of Lord Shiva, she got trapped for many years. She could not descend to earth. After many years and several seasons, she disintegrated in 7 parts, and these 7 parts eventually descended on earth. And when they were descending on earth, a bright light like 100 sun was observed. There was a loud noise. It descended in 7 streams, and these 7 streams created chaos on ground. There are also stories that certain souls were liberated, so we do not know what is the exact interpretation. So we will consider various rhymes written in Sanskrit, translated in English, which will help us to understand what they were trying to say or what story they were narrating. Was it basis a certain observation, or it was a complete work of imagination? So Ganga, whose waves in heaven flow, is the daughter of Lord Snow. Wind Shiva that his aid be lent to hold her in mid descent. For earth alone will never bear those torrents hurled from the upper air. So it's very clear they are talking about a celestial body, which is a daughter of snow, whatever, maybe a snowy object. Its vega or velocity is considered as a main threat. And when they talk about Shiva, they specifically use word Dakshin Murti. Now in southern India, there are many sculptures which depict this event wherein Lord Shiva is holding Ganga on his head. Lord Shiva in celestial context is considered as a belt of Orion. That's what Dakshin Murti is. So if we look at the figure 4, we can clearly see a celestial object with tail. Object 2, which is Lord Shiva, is nothing but Orion. Exactly behind Orion, there is a dog, because belt of Orion is shown with 2 figures, the 2 dogs, Canis Major and Canis Minor. So Canis Minor can be seen in this.
Mahesh, you have 1 minute left.
Yeah. So we feel that this depiction is about a cometary body which is coming down. So when this body came down, first it disintegrated in 7 parts. That is the key aspect of it. It never ever came down directly, and it spent some substantial time. This is a typical behavior exhibited by short period comet. What they say when it was coming down from the sky was all aflame. Bright light like 100 sun was observed. Clouds were white and gray. Okay, these are the typical features. This is the meteor of 2013 Russian meteor. So most of the features described are of a plume or a object, celestial object entering. Impact pattern: 3 fell on the east side, 3 on the west side, and 7th was a airburst. Now this is a typical feature which seems like something similar to Schumacher-Levy. This is a drawing, or this is an old ancient. It's a World Heritage Site in Chennai, wherein the event is depicted. We will refer only 3 points. First figure, if we look at, it is of serpent. So we'll start with second figure, in which humans are observing the sky and offering their prayers. There are 3 serpents coming down. Now, serpent in river is not a sense, but yes, when we consider a comet in Sanskrit, it is called Dhoom Ketu. Ketu is depicted by serpent. So eventually, it was some celestial object like Ketu or a Dhoom Ketu which was coming down. Condition of human. There is a sarcasm in this art, wherein a cat is shown, where rat is offering his prayer. So eventually, condition of a human, exactly in front of a human figure, there is a cat and a rat. So condition of a human is expressed in a sarcasm, maybe by the artist. Even animals are scared because
Mahesh, I'm pretty much going to have to stop you. Do you have a slide, a conclusion slide at all that you want to share with us? Sorry.
Perfectly fine. No issues. So this is the place from where it was observed, the impact was observed. This is the drawing that was carved at the time of impact. That's what we feel. It is exactly in line with tektites and everything. So we are saying that there is a possibility that ancient Indians have observed certain events. If we compare the geological features of the region, yes, there are evidences of impact in the form of metamorphic evidences like Cosite, Stishovite. There are tektites in the region. They start from Tibet, and there are certain structures which have appearance like craters. Obviously, yes, field investigation is required, and we are looking for association on the same. There are few Vedic things which we will just show it for a second, if you allow me. They clearly say they have mentioned it as a record. It's an Adbhuta, strange event. Comet was observed for previous many dawns. It is in the form of transient fire. It's roaring and driven by red animals. It is in the form of multiple fiery objects with smoky extension. Observer is requesting protection, okay, and drops of this fire eat burn grass. So obviously, ancient people have seen, even in China, there are records. So if there are any questions, I'm happy to take.
We'll probably try and do the questions offline via the chat and the question and answer, if that's okay. But thank you very much for that. That's really, really interesting. And it's amazing how these crater impacts from all over the world seem to relate to different histories and different transcripts. But yeah, thank you very much.